Yeah, alright. Back again for another adventure in draft physics. Alright. Something like that. Um, so, comments. Uh, and we'll see. Maybe comments on other people's videos if I can't find enough of my own. Or something like that. So, first subject. Could you comment on this video and explain electrons' interaction with magnetic fields? Sorry for it's Japanese. I'm not going to bother playing it because it is Japanese and it's rather slow getting to things and blah blah blah. But it's this electron gun thing, when you put a magnet in and it deflects certain ways. Now the trick to these experiments is they do them in different ways. You can fill the tube with the electron anode cathode thing. All right, so the basic idea is you just take an electric current. And these things are metal, and you put it in a vacuum of some kind. Now the trick is sometimes they put a gas in there. It's a three-letter word. I can spell that one. And so that makes it a little tricky. And then the other times they'll put a fluorescent, fluorescing compound of some kind, a flat sheet. And so then you can see the beam, move along and such. And the problems are, there's a couple of problems with these different techniques. The idea is that these electrons, so one end is positive, one side is negative, it goes from the negative to the positive. Actual, materials coming off of this thing. And the electrons don't just fly in nice straight lines, as pointed out. They kind of go in all kinds of feathery directions naturally. And so what happens is the one you see are actually, when they use a fluorescent thing, are actually ones that aren't going particularly straight. They bang into the metal. So they're kind of giving you a notice that this beam is kind of fuzzy. It's not a straight line. It's a fuzzy line to start with. So what you're seeing isn't necessarily what's actually happening, is the point I'm trying to make. Not that I'm disputing anything that they show happening. I'm just pointing out that it's a little more complicated. But sometimes they can make the beam, like they'll put a magnet in and the beam will go up. You'll say, why is that happening? It shouldn't be going up. And that's usually when they're not using the fluorescent film, but they're using just a gas in there. And what you're seeing is the atoms of the gas are actually being polarized. So they're still dipoles. And so they're not going to move like an electron would move. They're going to move a little different than an electron would move. So that's where it gets a little complicated. It's not just an electron gun then. It's an electron gun that's hitting atoms. And then the ones you see are the atoms it hits. The electrons that don't hit an atom, you don't see. See, that's the trick of it. So it's kind of filtering what you see. So you're only seeing a component of the beam deflecting. But the traditional idea is that I can put another source in here of positive and negative, and I can deflect the beam up or down. And it's just kind of obvious that the electrons are going to be attracted to the positive and repelled by the negative. And so it all kind of depends on how you apply the magnet, right? If you apply the magnet with a north end and a south end, or vice versa. I could do the red thing, but you get the idea, right? There's two sides to the magnet, so it kind of depends on how I orient the magnet is going to decide how the beam, which way it deflects. And so there's just nothing terribly dramatic about any of this. The electrons themselves are just little charged entities. They radiate charge when they're exposed to a charge. So when you expose a charge to another charge, all right, like the pole of a magnet, the pole of the magnet's a charge. Essentially, it's behaving just like it was a charge. And then you have this potential for reflections, or the inverse, when they're opposite charge, you have the deflections. And so that's all that's happening, really. So I don't know if it needs a great deal of explanation. It's kind of an effect I've shown in the past. It's what cathode ray devices do. They they're not really electricity as stated. I mean, there's actually material lost from the anode to the cathodes, and it's just they're electrons, presumably, mostly, probably some atoms too. But anyway, all right. And ions and all kinds of stuff flying through with the electrons. But anyway, mostly electrons, probably. All right. Hope that answers the question. Okay, love the basic definitions videos. Yes, I think that's the way to go. It really showed that you tried to leave your comfort zones. I don't think that's what it shows, but whatever. I'm just trying to get to an honest evaluation, and then the sort of the argument is that what really people are arguing is interpretations of experiments. How seriously you can take the results, how precise they are, all of that kind of stuff. It's like the Eddington experiment. People who want to believe light is bent by gravity see it as a glaring piece of great evidence. And people like myself who see no need for light to be bent, I mean, I wouldn't be totally opposed to it, but yeah, it doesn't make any sense to me why the photon would be bent and all of the other stuff, magnetons and all the rest of them can't be bent. All the other stuff moving the speed of light is not bendable. Forces don't bend. They hit things. So it doesn't make any sense to me. But clearly it should be agreeable that it's a marginal experiment, that even theoretically, the theory of doing the experiment is marginal, in the sense that it's such a small difference you're trying to detect. It's insanely delicate. And that the margin of error calculated by some strict little rules about how good my ruler is doesn't tell you anything about how delicate the experiment is, in the sense that the margin of error, there's a huge margin of error in just misreading your rulers and your eyesight and all of this stuff it's dependent on. So the margin of error isn't as simple as just calculating decimal points. It's substantial. And the fact that it hasn't been repeated successfully, that is, getting past the margin of error results, just demonstrates it's crappy evidence. It's not the kind of stuff you should base your belief on. And then I can point out how these other experiments, like the slit experiments, that they really don't do what waves do. That what happens in light is different, even in the two slit. I mean, it's obviously different in the single slit, and it's, in a sense, obviously different in the multi-slit, in the sense that images are being transmitted. And even in the double slit, the one that looks the most like it, there's two patterns in the light experiment, and there's only one pattern in water waves. So it doesn't have this huge correlation. So this is all just arguments about interpretations. And somebody leaving your comfort zone is just saying, okay, what does the evidence really say, and how loud does it say it? All right, the worry, the one comment expressed about you fading, I don't think I'll fade, I think I'll just drop dead, but whatever, becomes relevant when your stuff enters the stage of public debate. No, it becomes relevant only in the sense that we see what they do to people. They quote mine them to pieces, right? I mean, Einstein, for people who want to make him a god botherer, they can turn him into one by taking one of his quips, one of his jokes, and taking it seriously, and then say somehow Einstein wasn't a pretty firm atheist, even though he said, look, I don't really have time for these kind of movements. I don't need to, he clearly didn't want to offend anybody, didn't want to take a stand. But he clearly also showed no evidence that he gave any bother to anything called a creator or intelligence creation. He made this Spinoza comment to his God is just nature, blah, blah, blah. But obviously people will, do that. And so then even Einstein's physics, Einstein is now somebody who says gravitational waves as a theory has credibility, when he didn't think so. It's a fact. So all this stuff is, he's you get totally perverted, and that's so. The only problem is, when you're dead, you can't defend yourself. You can't even defend your own words, and that's a big problem because we just see what people turn other people into by quote mining them and essentially distorting what they've said in the past. All right. Currently, I wouldn't see myself capable of to explain all the points and dissect the potential counterpoints efficiently and on the spot. Okay, well, 2 plus 2 plus 2, that part's pretty simple, right? 2 kinds of force, 2 kinds of matter, 2 kinds of interactions. That part's pretty hard to mess up. Now, obviously, when you get into the details of gravity, and it's the fact that the gravity is created by the storage element is the fact that gravity creates heat, and heat is the evidence of the delay. The fact that there's a bunch of motion in the earth or in the sun or in anything that's gravitational, that right now there's parts of you going down because it's being accelerated down, and then there's parts being accelerated back up. And those 2 parts are both real movement, and the real movement has to be accounted for as what's pumping it, what's providing the energy for the movement. And so the fact is that you don't really fall into the gravity you create, you fall into the gravity the stuff below you created. But anyway, so yes, it gets more complicated, and every subject has these subtleties, like we pointed out with the electrons, the electron gun. There's a subtlety to understanding when you're seeing the beam as it collides with atoms through an atmosphere, and when you're seeing the beam because some portion of the beam is hitting a fluorescent material. These are different ways of seeing, and the details matter. Okay, anyway. I mean, I'm elaborating a little more than I should probably. And seeing as even if I see 90% of comments, and seeing as even if I see 90% of comments not getting it, well, clearly, and the ratings just are glaringly dismal. Nothing you can say. It's that obviously people aren't very excited. They aren't very compelled to support in any way. So, that's disappointing. I mean, clearly 2,000 subscribers. You wonder what people are watching. My eyebrows move a lot, so maybe that's it, His eyebrows move a lot. Yeah. Maybe that's what they're watching. Anyway, either falling in verbal traps or misinterpreting or combining assumptions wrongly. Well, there's clearly an awful lot of that. I don't know. I think I'm being quite clear, and people ask questions and say, well, didn't I just overtly answer that question in the video? But anyway, I fall mostly in the latter category, leaving my presentation capabilities wholly, not wholly. Okay. Well, I'm not really asking you to present, but anyway. So yeah, there's like maybe 200 people on the planet combining all the necessary traits to take up the baton. I think there's probably more people than that can be rational, but it is curious that just people are sort of devoted, aggressive. It's like politics or something. I mean, the issues get lost in the idol worship and the routine, and the traditions. I'm a traditionally this, and so I will not turn into that. And I don't know. Truly curious. Authority rejecting, non-corrupt, to my knowledge, and so on. Yes, truly curious. I would argue that I've always, frankly, from my point of view, I've just wanted to know the truth. I mean, I really haven't had some sort of pre-existing bias. I mean, I was a huge nature lover in a sense as a kid, and but I was able to realize that nature sucks. It sucks balls in the worst kind of way. I mean, it's just a maniacally evil. And, so even though I would like to be pro, I can't be. Just because, just like I'd like to be able to care for everything on Earth. I know as a practical matter, that can't be done. Because there's too damn fucking many of them. That is where I see the loss mattering again. Okay. Well, I just see it in the details. Again, like I said, just as you see what they did to Einstein, they keep putting Einstein's name on complete batshit stupid science. Anything to do with any, wacky. I like it. They blame it all on Einstein. Like somehow they put Einstein's look, it has credibility because Einstein thought so, and Einstein didn't think so, and didn't think so overtly, and they still put his name on it. Now I'll bombard you with potentially rude, nitpicky questions without reiterating the points we've already agreed on. Okay, it really is fine. I mean, I don't, it's not rude to nitpick. It's just rude to do it in some sort of way where you imply that somehow I haven't answered the questions or somehow I've evaded them or something. I haven't evaded them. Can you see that near incalculable spread of radiation? Can you see that the near incalculable spread of radiation in the cosmic background could be interpreted as your hypothesis, dark energy? Well, I'm just saying it's dark energy is implying that the energy has one initiative, that is to push things away, when it could just as easily push things into each other. So that's where I'd say dark energy doesn't fit, because that dark energy seems to say that everything is repelling each other. Everything's expanding from some point because space is expanding. So that's a little bit different. Dark energy comes from nowhere, where the cosmic background radiation specifically comes from the outside in. It's always kind of, how to put it, it's always on the outside in. I mean, it's always coming from over there. You never get to the over there where it's coming from. So it's always outside in. So it clearly would push the universe together, where something like, if the cosmic background was thought of as coming from the space itself, like the space between us and the moon, that somehow the cosmic background radiation is coming from there. I'd say there's no evidence it comes from there, in the sense that I think the evidence is that it's old radiation, not new, and that's why it's redshifted and all this other crap. So, yeah, it doesn't fit for me personally. So, yeah, I don't know what to say. It just makes a huge difference whether the radiation is, like I said, it no matter how I place the radiation, as long as it's placed in symmetry, there's a balance of the force. And what we're really talking about is energy as I'll be one of the words I should define, is just in balance. Your energy is only observable when there's an imbalance in the field of force. All right. I don't know. Best answer I can give you, I guess. Does your model favor... I mean, I just wouldn't call something dark energy. It's either is or isn't. Energy is a real thing, okay? And energy, again, is the byproduct of an imbalance in fields. Where's the imbalance in the cosmic background radiation? So I wouldn't call it energy. Anyway, does your model favor a finite universe where the edges reflect the radiation back to the inside? Well, I would argue that that's an easy thing to imagine. An infinite universe is a little harder to imagine, okay, frankly. But, yeah, who cares? I mean, how can it matter one way or the other to understanding the mechanism that exists now? How it was created, I just don't think it matters. I can believe in evolution and believe it, so well that I would risk anything and everything I understand, the welfare of everything I've ever loved, or, my having a roof over my head, everything, on the fact that it's a fact. And I don't know how abiogenesis exactly happened in any way. Can't really say what came first, chicken or egg, all this kind of bullshit. I don't, those questions just aren't important. The mechanism is overt in its display that this is what happens. And I'm just arguing that it seems clear. The only way you can really rationally explain magnetism is to create two forces in two kinds of matter. And then it works perfect. Anyway, does your model favor a finite? Okay, isn't there so many more directions for disposition of momentum than for reflections? Dissipation of momentum than for reflections. I would argue that whatever, if it is a bubble verse, the argument would be is that all kinds of radiation hit the outside. Okay, ultraviolet and cosmic rays and this ray and that ray and all kinds of photons hit the outside, and they all bounce back broken. Okay, they all bounce back as just the little bits in all kinds of bizarre sequences. So you don't see what comes back. It's gravity that comes back. All right. You often use the word perpendicular for the force matter DE reflections. Do you mean literally always 90 degrees? Yes. I think the geometry is rather rigid. Or a general sense of sideways like a magnet does it. Magnets are a field. So the reason why they reflect in some various ways depends on how deep you go into the field, how close you get to the magnet will decide how much you turn. So it's a gravity argument. So it's a little different. All right, what the atoms are doing is charge. It's not really magnetism from their point of view, because their point of view is always there either is an electron or there isn't an electron. There either is a proton or there isn't a proton. So I would argue that their movements are much more rigid, but whatever. Or do you think it becomes precise again at the smallest scale? I don't think it matters one way or the other, frankly. The basic end is that you're trying to conserve this idea of momentum in a direction. And I guess sort of fundamental to the theory is that yes, you conserve momentum, but because of the action of protons and electrons, you don't have to conserve direction. So you can change direction for free, you could argue. But that's because of kinetics, that there's no friction. Is there a limitation for the angles in which force specifically can be deflected? I just don't know theoretically whether it could matter. I don't think you can get that fine a grain of detail. But I would argue that it just doesn't matter. Like, you know what I'm saying? I would argue that obviously the range in a three-dimensional universe, you move forward in a direction, okay, and then you can, in the two dimensions, add a vector, right? So we're always talking about 180 degrees this way and this way. I'm just saying those average out. So when you take 180 degrees and you get the average, it's 90 degrees. So I'm just saying, even if the other stuff is happening, it's probably irrelevant because it all averages to the 90-degree turn, if you get my point. So I'm just saying this minutia, or this, getting micro, I'm not saying it's a bad thing to do, but it's really not to my advantage to get into that more complex argument, when I would argue that I don't think we have experiments that will demonstrate it one way or the other besides the outcomes. All we can really see sometimes is what do 1,000,000 electrons do, not what one electron does. And the 1,000,000, on average, turn 90 degrees. But I would argue that, yes, it's clearly possible they're doing this, and they're doing this, and this, and all of that averages out to 90. All right. Anyway, okay, is there a limitation, is there a limitation for the angles? Okay, like the force bits being cube-shaped, for example. Yes, shape could be a factor. Could be why they don't hit each other. Could just be because of the way they're shaped. They could be pointy little diamonds, and they just, rub up against each other, turn, and then wiggle back to the same direction, or some kind of bullshit. Who the hell knows? Again, I just think it's such a level deeper than this argument. This argument is this conventional physics is full of woo and really bad guesses, and that ought to be fixed. Okay, that's it for now, especially the first question burned in my mind since the first video I saw. Hope I raised some new points in terms of comments at least. Yeah, well, frankly, like I said, I think it's a level that it really isn't to my purpose to make it any more complicated than it has to be, in terms of making the clear argument that this model works to explain what we see. Their model really doesn't. So I'm trying to think of what the first point is. The background radiation is dark energy. Yeah, I just don't see the point in trying to come up with pushing and pulling forces in the entire universe as some kind of real thing, because I don't think it has anything to do with the basic mechanism. So I would argue to you that what I tend to think, okay, with whatever 60% confidence, 65, is that maybe 70, is that it is an oscillating system. That the key to the fact that the old universe looks different than the new one, the photons we see from things that were long past, looks like the matter is much more consolidated and much brighter, indicating that gravity has degraded over that time. That gravity was stronger and now it's weaker, so that the pressure pushing things together was more intense, and now it's less intense. And the argument would be as things start breaking apart, more of the energy is free to become gravity, and so it's increasing the gravity as it expands. And when it expands to a certain point, then the gravity becomes so strong it pushes it all back together again, and then there's less gravity. So in a sense, the old universe had less gravity because we were seeing it after it was compressed. But once it's compressed, that means all the little bits, the heat, isn't in the free universe anymore. So now it's going to expand into that space. It's the pressure isn't always the same, because it goes from proximity being close to spreading. The force on the matter expands, and when that happens, there's eventually the system fights back and creates more gravity. That is, eventually that extra energy hits the bubble, bounces back, and now you get hit with a compression wave, so to speak. A period of compression. And then there's less stuff hitting the border and bouncing back, and you have a period of decompression. There's a delay in the cause and the effect. All right. Appreciate the comment. Thanks and such. Oh, another one. Same guy. Oh, and today I first heard of the two planes of red and black as an explanation as to why they don't interact. Well, like I said, there could be lots of explanations. It could just be a shape thing. Could just be the way it is. It could be that they're so tiny. I can make a photon, the actual thing carrying the momentum, I can make it any size, right? Because it's just a quanta of mass, and I can make that mass any size, because it's an elemental hunk of mass. So if I make the photons small enough, well, yeah, they never hit each other, but they're so damn small. Anyway, as an explanation as to why they don't interact. On a gut level, I don't like it. Well, whatever. Who cares? Fine, probably don't. It kind of lends itself to the geometry nutter, the parallel dimension universe fanatics, and to an extent to the etherist. I don't see how you connect it to that too much, but fine. Or did you just mention it into level with Franklin Who? I'm just saying that if you're going to make the argument why these things don't hit, why the red and the black energy don't hit, because that's the only part that matters, right? If the black energy was all there was, it wouldn't matter whether they hit or they miss, right? As I've pointed out, in pure kinetics, it just doesn't matter. They'll replace each other in their function, okay? So two things did this and reflected. It would be exactly the same universe if they missed each other. You couldn't tell the difference. And all I'm arguing is because I have two forces, to create magnetism, and to create the unique behavior of protons and electrons, then you have to, then you could see it. If this was red and this was black, this universe is going to look different than if they just went by each other, because black's going to be going this way in one universe and red's going to be going that way in the other universe. So again, I could just argue that the two planes of the universe just don't match, and it's only when they hit a piece of matter, okay, that you can see that difference, where the two planes meld together, because the matter bit is bigger than the cross-section size of the planes of the universe. All right, kind of feels like a blemish on the real vacuum you fought so hard to establish. I don't think it changes vacuum any. I'm just saying it's such a tiny distinction to say that the black squares don't blend into the red squares on a checkerboard is not exactly a hard concept, to say they're different. So I don't see it as all that big a deal, but whatever. I'm just saying, then come up with some other reason. The black bits and the red bits are shaped such that they always deflect off of each other in a way that's benign. They slide over each other or something. Anyway, I don't know how else I would describe it. Okay, well, whatever. Comparing them to magnets who repulse each other would beg the question of why they go through the trouble of going around each other and missing each other. Well, they're obviously not radiating a force, so they're not like magnets at all. They're not charges at all. So I don't see any point in that comment. Making them into donuts or donut holes would beg the question about precision. So, you want to talk about the shape of photons. We can't even define the shape of electrons, and you want to do photons. Whatever. I'm just saying, if that's the kind of detail you're looking for, that's not my mission at all. I'm not going to give you a creation story. I'm just arguing with conventional physics, silly entanglement, their silly time is a dimension bullshit, their nonsense that gravity is somehow a different force than magnetism and electricity. That's what I'm arguing with, not this. I'm not going to tell you what photons, what shape they are. Making them to real physical limitations is circular. Well, whatever you say. So basically every kind of why do the planes respect each other's territory to the point of becoming rails? Why are the black squares different than the red squares on the checkerboard? I don't know. Sorry, it's hard to sound respectful of your body of work while trying to be to the point. Well, I don't think your argument is to any point. No physicist, only a storyteller or a religious kook is going to give you your creation story. There's just not any going to be this. We're not going to be able to glean enough evidence to draw conclusions. The reasonable explanation is that I'm looking for sturdy answers. Well, you're not going to get sturdy answers to those questions. I should give when asked, and you. I have already done the work. When you have already done the work. I don't know what that means. But anyway, I could watch more of the older videos, but you mentioned recently that some of your assumptions have drastically changed. obviously when I started, I had no theory of magnetism or electricity or any of the other stuff. I was just arguing that gravity is in fact Mach gravity. It is a particle gravity. It is the Lesage theory works if you just modify it a little bit. And I hadn't come up with the two-force idea and all that stuff. I was just doing the absorption of momentum idea. And so, yeah, there was different arguments. And my arguments against drag were kind of lame and weak. And, lots of stuff was, I just didn't have as precise and as detailed a model as I needed. And so it's, it's good that it got criticized, and I had to fight for it, and because I made it better. Could you summarize the most prevalent ones in a mistakes I used to make video? In a similar vein, the basic definitions. Okay, now I'm done. Yeah, well, that's the point I would emphasize, that there was always a view, okay, of, like, for example, photons. I've been clearly honest in stating I never believed in the wave photon thing. It never. As soon as I heard it, I said, no fucking way reality works that way. Just no fucking way. It's bullshit. Especially as drawn. I mean, the light isn't doing that. It could be on and off and on and off or something. It could be blinking lights, or it could be lots of things, but it ain't no fucking, nothing does this for no good reason. I mean, as an elemental function, it does this. I mean, that's defeating the whole purpose of physics. Physics is supposed to explain why something bends and why, that's the whole point of gravity. You don't say, oh, it just is. It just circles the sun. That's all. It just does it. What do you mean it just does it? It doesn't just do it. And this would have to do this for a reason. And there can't be any possible reason there's any of this bullshit going on. Fields vibrating in directions and completely undetectable effect. It's vibrating. It's supposed to be doing something in some field, and yet the field isn't disturbed at all because I can't detect any disturbance in the field. The whole thing is just crap. Well, anyway, so that's the thing that I'm fundamentally arguing for, is that's the first point where physics became bullshit and everything else is just layers of their bullshit. So I'm really fighting their bullshit, not so much building a model. But the point is in fighting their bullshit, you can find the alternative right answer. So the point is in saying, I know that's wrong, you just end up tripping over, what must be right. I mean, if you don't get the wrong answers, the right answers are kind of simple and obvious. Like I said, 2 + 2 + 2 physics. The right answer is so simple. All you need is not to have the wrong answer in the way. If you put the wrong answer in the way, you just won't see it. The right answer is right there. So I'm just saying that my advantage was I didn't accept the wrong answers. So my eyes are wide open. And I can see the obvious right answer. And it's more obvious than I even imagined it could have been. All right. Gary, even though I agree with some of your points, I have yet to be persuaded that there is no ether, aka counter space. Well, as soon as you call something counter space, you've left the rational building, in my opinion. That's like using some archaic terminology from the Bible or something, and thou shall blah blah, all that. That's just mumbo jumbo bullshit talk. I mean, counter space, that's like unspace, or I mean it's like unrunning. Why would I say he's unrunning? I wouldn't say that for standing still. Why would I use a concept like counter nothing? Oh, you mean something. You don't mean counter nothing. You mean something, right? What the fuck is that jargon? Except jargon. Right? That's just such crap. We know this word space is totally associated with empty things. Empty things have space. Nothing. Space is clearly a synonym for nothing and empty and void and all of those kind of words. And to say, counter void, please. Oh, you got the counter wrong answer. Fuck you. I mean, that's just bullshit. So I'm just sorry. That's Ken Wheeler baby talk. That has nothing to do with trying to even communicate with other people. So if you're going to use the word like AKA counter space, you've just said to me, I'm a religious kook. I don't want to have a serious conversation about reality because I'm going to use nonsense jargon and call something up, down, undown. Oh, it's undown. Fuck you. All right. I have sufficient evidence. Where? So fine. You have it in your special vault somewhere. I'm pleading with you. Show me one shred of fucking evidence that there's some... the key thing about ether, too, is they have to give attention to make it work. That is, all the little bits, like water molecules, have to somehow be connected to each other. Right? That's why water spreads in all directions. It's because every single movement of every single atom is going to move all the other atoms. Not just the ones ahead of him, but the ones this way, and the ones below him, and the ones behind him. All of those are going to be perturbed by his movement. And I have clear evidence that there's no evidence that's happening to anything traveling through the universe. So it just don't work. All right. It's such a meaningless thing to say anyway. I have sufficient evidence to suggest ether is real. What? Did you talk to it? You had a personal relationship with the God ether? What are you talking about? You have sufficient evidence. Where the fuck is the evidence? We as a species do not have the technology, so this is just more bullshit. Somehow this has something to do with us as a species. We don't have the technology to explore the inner space. No, there's one universe, the small one, as I've pointed out. That's where all the laws really are. There are no laws out here in the big universe because everything happens because of what the little bits are doing. Period. But we do have pretty good vision. So this is just bullshit. The inner space of Planck-sized dimensions. Obviously, we've done pretty well to even establish those dimensions. But I'm just saying the thing you really have to be careful about is, recognizing that we're watching the universe based on how electrons move fundamentally. Without electrons moving, we don't see anything. And how electrons move is Planck. That is, you gotta hit the plank with enough force to make the plank fall down. And any less force than that, you're not going to see, because you only see planks falling over, in a sense. Okay, so we said the electron was a plank. If we called the electron a plank instead of an electron, you'd sort of get the idea that, we just see planks falling down. So we only see things as quantized because it either falls down, either knocks the plank down or doesn't knock the plank down. Doesn't mean there wasn't any energy. So again, I just call bullshit on this idea that we need to see more to draw basic conclusions. I'm just saying there's plenty of evidence, again, that there's no ether because things like photons travel billions of light years without being degraded by an ether. The tension of it. The fact that they would somehow be perturbating other things besides the thing right in front of them. That they'd be dragged to death. Alright, anyway. Sorry, I'm unimpressed by your unevidenced argument. Alright, thanks for responding. IDK, I don't know what that means. What that guy was saying, you're going to die. Yeah, I mean, it's kind of rude. But anyway, your ideas are recorded just like any book. Yes, it seems obvious. I don't know why he has this perception that I drop dead and my videos die with me or something. So why should I care if you die? Exactly, you really shouldn't. As long as I still have your videos, it's fine with me. yeah, again, the only argument I would make is clearly I've said things in context, in circumstances that somebody could quote mine and they could say I believed when I didn't. Obviously, you could take stuff I said 5 years ago and some of it was just plainly wrong. I made invalid arguments. I've done it. I mean, I'm not gonna delete it. Because I think that's unfair to the truth. But somebody has to be decent enough to recognize, oh, that's not his current better perception, what he believes now. There are important distinctions. It's not his best argument, let's just put it that way, on that particular subject. So, that's all I can do. Is point out that you can't defend yourself when you're dead, and that's unfortunate. And there's too few people that'll defend your corpse. Like nobody's defending Einstein except me, ironically. And I don't like much of what Einstein imagined, beyond him recognizing the universe is mechanical. It's whatever it doesn't do it for any spooky reasons. Alright, anyway. So that's all there is for comments on my video. So maybe we'll just go to the Saturday Science chat. One guy posted a bunch of crap. He says, blah, blah, blah isn't an argument. Yeah, it is often. That's the argument from, we've already done this and been there and done that. Shut up already. Make a new argument or just shut up. Alright, questing is a real douche. Sorry. Anyway, atomic physics and cosmological systems evolve from the processes optimized for exploiting energy. So again, they can't exploit anything, in a sense. They are victims of it. Just as we are. We don't exploit anything. We are exploited. Your environment makes you. You don't make your environment. That allows for its existence in the same way that life did. Oh, this is just, such religion. Life does. But atoms exploit an energy in space. So all there is there's either something in your space or there isn't. If I'm alone in space, I'm not charged, I'm not anything. Okay? I'm just, stuff comes in and stuff comes out. When I put something else in the universe with me, now my world is changed. Because now I can have reflections that get trapped between me. And now I can have diversions that make all the force moot. And so now things can happen. I can be forced into an interaction. Yeah. I can be pushed all over the place. Let's see. In space, and convert the energy into atomic force, which, this is just more baby talk. The energy is converted into atomic force. like, what does that even mean? Oh, you mean the magnetism's turned into electricity, or the electricity is turned into magnetism, or some kind of thing like that. Atomic activity. We then measure the force generated actively and call it time. So this is more nonsense. I don't even know anybody who does that. We then measure that force generated actively and call it time. And I don't even think the wacky time dilators believe that. So whatever. Sorry, that doesn't make any sense. It's just nonsense. Anyway, universal structure and processes are highly organized and complex. What a bunch of useless crap. The idea is it's not more complex underneath. This Rube Goldberg machine is made out of things that aren't complicated. Sorry. The details of atomic and cosmological complexity are the same type characterized by biology nested. So this is really bizarre. I mean, to compare biology to the cosmos is just so frickin' insane in terms of, obviously, the the chemistry is a lot different in terms of the levels of complexity, just because of the fact that you have this capacity to make this almost unimaginably, almost infinite amount of compounds you can make out of the 100 elements, and none of that's happening in the universe. Complex systems within complex systems. Oh, whatever. This is just baby talk. It's all so complex. No, it's really not. It's asteroids crashing into planets, each layer reliant on the other above and below. Whatever. Atoms achieving many of the same types of activities as cells. No chance. I mean, it's just amazing. Binding together to form bodies. Yes, in this very crude way. They either have a free electron or they don't. I mean, they don't. They attach in what is really mechanical ways that we have quantized, essentially. So again, wrong answer. Atoms using gluons and electron bonds. Where a gluon? Show me an atom using a gluon. Animal cells using collagen bonds. More bullshit. Why would an inexplicable accident generate these types of nest? Oh, this is a religious kook. Theory needs to account for universal complexities. There's no universal complexity. There's really simple stuff, and then there's really complicated stuff. And the complicated stuff usually has to be in a very isolated environment. Via an adequate creation mechanism, whatever. Darwinian progression is the only natural organizational principle we know about capable of generating highly complex system. Join the dots, people. So what, there's a DNA molecule inside of atoms? I mean, what? Fucking idiots. Okay, so this is some whatever bond bidding turd. Turung. Well, whatever. Hi, Franklin. How do you accept that gravity is a form of light? How do you accept that gravity is a form of light? That's not a proper question. Clearly, gravity is a force, light's a force. All the stuff moving the speed of light is the same crap. The stuff that has a frequency, it's an obvious difference. I can have stuff moving the speed of light, and then I can have stuff that has a frequency. And then I would add the third ingredient. You can have stuff that is proton stuff or electron stuff, in the sense that it has it can be detected by a charge as different. And that's it. That's all you got. 3 types of stuff. Mixed and not at a specific frequency, at a specific frequency, and segregated. Not complicated. Can you imagine light, EM waves, not waves, waves are emergent, as a form of gravity? Yes, of course you can. Gravity hasn't to be a special frequency of EM waves. Okay, so I think he meant gravity doesn't have to have a special frequency. Did you ever seen an EM wave which does spread in a cone? I guess it's more, what are you talking about? I did so far. I didn't so far. Again, you can't see light. You can only see its effect. So this is more nonsense. If I see a laser beam in front of me, I'm seeing the light that actually isn't going where the laser beam's going. I'm seeing light that's scattered off a piece of dirt. Anyway. So EM waves may be a bundle of cylindric gravity waves spreading in cones. Why? Why would they have to do any of that stuff? They go from point A to point B in a straight line. This gravity acts stronger at the value of the Coulomb constant and fades. Whatever that could possibly mean, I have no idea. To the gravitational constant, the more particles are clumped together. The simplest argument you can make is that anything that has any matter that has momentum, that is, it's moving in a particular direction, means it had to interact with something that gave it that force, and that usually the interaction has to be in the form of an exchange. Like when I'm playing pool and there's a ball just sitting there, and I hit it with another ball, okay, that has momentum, what happens? The momentum goes into the ball I hit. And the one that did the hitting, if I do it right, will just sit there like, hey, I gave him my energy. It's clearly something you have to possess, velocity. It's not something you can just have. You have to get it. It's a substance. It's a quantity of something. Jeez. This gravity acts stronger. Okay, we already did that. Charges can be made of some neutral particles, which again doesn't make any sense. Then how are they charges? Because charge can depend on the distance of two particles. It's only in a dipole where distance becomes significant because the two forces blend into each other. Because their distance is responsible for the way how their gravity waves will interfere. So again, more waves, this magical waving stuff. Everything's waving something. Waves. No. Now you can tell, again, Maxwell's drawings couldn't be more explicit. When he's showing you charges, they're straight lines. I mean, the ones showing the lines of force. Straight lines, rays. Now you can tell why EM is polarized and shieldable while gravity is not. Well, gravity is. It's just that you need something big. You need a big fucking shield. Gravity requires mass. Because gravity is an effect. It's a field effect. Alright? So again, you have to have something big. You're moving very slowly to absorb the gravity. Gravity's moving really fast, and there's a whole bunch of it. And the idea is, if you want to block it, you put something big, okay, really big, so it absorbs the momentum, and now it moves really slow because it's really big. And so it has to, move lots of other stuff inside of it. And so it absorbs the gravity by just moving really, really slow, and then you've absorbed the momentum. You've absorbed the force. To absorb a force, you have to have something dense that can move a lot of little bits inside of it, can get caught up moving inside of it in traps. You have to have the traps. Traps aren't made of nothing, they're made of something. You need atoms to make traps. Gravity is the last wave that stands when all other waves in the EM cone are shielded out. So this whole thing, this EM cone, what the fuck is that? See, nobody draws pictures of any of this horse shit. Ken Wheeler does, but you just overtly look at them and say, what the fuck are you talking about? I mean, this is going on, and then tornado this way and tornado that way. How the fuck does that make a magnet? How does that make two magnets attract each other? I can't make any sense out of it. I can't see how you get from there to two magnets repelling or two magnets attracting. He doesn't draw that picture. The transition, the missing link images, that show me how this transition took place. No, they're not in there anywhere. This may be a new paradigm for the grand unified force. The only one I found that seems to work. And I don't know how the fuck it works. No clue. Oh, these people are so fucking crazy. Nothing can travel faster than the speed of light. This will only be valid for all objects in empty space of the whole universe, because proper velocities can only be measured there. Whatever. Proper velocities? Okay. While resting in it. The only thing you can do is change the path of a photon. You can make it travel more distance, and then it appears to get to point B slower, but it's only because you bent the straight line. Speeds are distant over time, since time is a local determined value. Well, it really isn't, and especially isn't for light. So again, you're not even doing Einstein's theory by saying that. Einstein would never say a local determined value. He would have said, no, the speed of light is always the same. which depends on movement and gravity. Speeds have to be local determinations also. So says you, with slower clocks, so again with broken clocks, you'll measure higher speeds. Yes, because your clock is broken. Except light speed, which you will measure too slow. Where's your evidence for that? Remember, light between moving mirrors will take longer as light between resting mirrors. Says you. Defining time as a specific count of reflections at one mirror doesn't tell you that you're moving. Well, what does tell you you're moving is looking out the fucking window. Alright, a time of 100 counted reflections will take as longer the faster you move. Yes, okay, granted. Same speed take lesser counts, so equal counts. Well, anyway, so these arguments are just useless and don't really get to the point. And I think the obvious point is as Einstein, if we're going to take Einstein seriously, let's just take it seriously. The prospect that light isn't time dependent. It defines time. The speed of light defines time reliably in all frames. So the whole frame thing doesn't mean anything if you all have a light clock. Anyway, light can't be any kind of particle, says you. How would you name particles made of a near superfluid material? So more just jargon. Superfluid, which become more solid the more of these particles are densed in one single place. Edit. Well, wavelets sounds good. I don't know. It sounds horrible. Edit 2. I guess again, particles made of near superfluid material seems to be a new paradigm too, because you always talk about particles to have to be solid. Well, the whole point of the argument is to describe something elemental, and if you're going to call it a particle, then it should be a particle. That means it should be assumed to be something of simple property. And if you're going to give it complex properties, then you don't call it a particle. You don't call a battleship a particle. It's just, it would be, it just wouldn't make any sense, because it's clearly not something of simple, rudimentary function. If wave particle wavelets aren't solid, there hasn't to be any ether, and light can be made of those special near superfluid particles while not losing any of the characteristics. On the contrary, light gets even more property the higher the density of the wavelets and the higher the mechanical resistance. Solid particles made of wavelets. I mean, so what's the point? Particles made out of waves. I mean, it's just, pointless nonsense. I'll just add, I did read a couple of Miles Mathis finally posted some new articles. He had some trouble with his internet or something. I mean, it's just kind of funny in 2020 and you still can't figure out how to use the internet. But anyway, it's hilarious even. Go to the drugstore, so many ways to get access if you really have to. Anyway, what was I going to point? Oh, so yeah, so I read a couple of his pages, and it's all just gibberish as far as I'm concerned, because he bases everything on spin. So everything's spinning. And again, you say, where does this momentum come from for this spinning crap? And so he has photons and anti-photons, because he has them spinning counterclockwise to each other, which again in 3 dimensions just sounds like horse shit. But anyway, I mean, people just, they're replacing a bad, complicated theory with something that's badder and more complicated. And it's just so the wrong direction. You're looking for a simpler, more complete answer, not a more complicated, easy to break answer. I mean, these theories are just so easy to break by just pointing to one experiment and just say there's no evidence of anything spinning. But anyway, so enough of the video. So until the next time. So I'll probably do another definitions video. Still working, it's on definitions, but just like the things like energy and field and some other words that just need to be pointed out, that fields are just fields of. They're not fields. They're fields of. And the of is force, and the force is in the bit form. Okay, there's little bits of momentum moving in a direction. So essentially it's, field theory is correct in the sense that the universe is just points in space, and that point is moving in some direction, or that point has nothing in it. It's either a something moving in a direction, a little bit, or it's nothing. And that's what the universe is made out of. It's all golf balls, theoretically. And every golf ball is heading in a direction. So the electron is just a collection of golf balls. They're a little tiny bit closer together. And the rest of the universe is golf balls, and the golf balls are hitting the electron, but the pattern inside the electron is deep enough. There's enough pattern where you can jiggle it around and it's still here. See, some things you jiggle them and it starts to fall apart and it erodes and it breaks down. But some patterns, you can fuck with them quite a bit and the fundamental pattern's still there. It doesn't get lost. So that's sort of a way to think about it. So it's just patterns that have been collected in the form of electrons and protons. And they're now a pattern that creates the phenomenon of charge, in the sense that the pattern interacts with the golf balls by causing them to reflect or deflect. That's it. That simple mechanism can explain everything. All right. So, until the next time, such. Unfortunately, there will have to be a next time, I guess. Never going to end. I'm just never going to get my satisfaction. It's just really depressing. It is. It's just depressing. Yeah. Safe.